Hey guys, unfortunately I've not had enough time to be able to get out a DIY project video. I'm going to be going over my 3D printer. This is a Prusa i3 3D printer. It's self-built and I'm going to be going over the 3D printer itself and some of the upgrades that I've made to it. So I was skeptical when I saw the price of this 3D printer kit on eBay. It was only £240, and for all of the things they included, I thought that was a really good deal. If you actually add up the price of all of the components put together, the guy whoever was selling this was barely making any profit off it. One of the reasons that the kit was really cheap was obviously it was self-built, so it just arrived in loads of different parts with some sketchy instructions that were in not very good English, but still it wasn't too complicated to put together. And also it's a rep-wrap 3D printer, so it uses a lot of open source parts and very cheap Chinese electronics like the screen and the controller, as well as the power supply. One disadvantage of DIY building a 3D printer like this is it does take a lot of time to fine tune it and get it right and get it to print good prints. And if you don't have a lot of perseverance and you don't really know what you're doing, then it's going to take you a very, very long time. And if you're a total beginner like me, it took me a good couple of attempts. I reckon if I did this again, I could get the next 3D printer working really quick. But to actually learn all of the different settings and different parts and how to make your prints more accurate does take quite a lot of time, but it is really good learning experience. If you do want a printer that you can just print with out of the box, then this isn't really what you're going to be looking for. But if you do want an experience, this is going to teach you about how to 3D print and how it works, then you can't really get any better than this, or any cheaper. So first off, I'm just going to say I'm incredibly impressed with this 3D printer. I think it's the best £240 I think I've ever spent, and I've probably put about 2 kilograms of filament through this. That doesn't sound like a lot, but it's actually enough to do loads and loads of prints. So very simply, the way that this 3D printer works is it's called an FDM 3D printer, and most other 3D printers like it are also the same type of 3D printer, and FDM stands for Fused Deposition Modeling. It basically takes this plastic, which is in a spool, 1.7mm diameter. This particular roll is ABS plastic, and then a stepper motor with a knurled nut forces it through this tube and down into the extruder, which is very hot, melts the plastic and extrudes it out a 0.4mm nozzle on this 3D printer, which then moves about along the print and gradually, layer by layer, builds up your print. So if you have all of your settings right, then the resultant part should be pretty strong and pretty accurate, and you can adjust the amount of the infill required in each part so you can make it very lightweight and completely hollow. So now let's go over some of the features. The extruder that I'm using is an E3D version 6 hot end, and this can get really hot. I think it's up to 260 degrees Celsius, so that's hot enough for almost pretty much all of the different plastics and filament types that you're going to need, and it heats up really quickly. This is one of the parts that I upgraded. The old extruder wasn't very good, and I've completely upgraded it, and it made a massive difference to print quality. The bed on the printer is a heated PCB bed, and it heats up to 100 degrees Celsius. It does take quite a long time to heat up to that temperature, but if you're just printing PLA and you only want to go up to about 70 degrees Celsius, then it's fine, and it doesn't actually take too long to heat up. But it does take a while to reach the higher temperatures. When plugged in, the power supply is very cheap and it's pretty loud with the fan, and I could get a new one, but it's fine. And surprisingly enough, even after hours of running it, it doesn't actually get very hot. The kit comes with an LCD screen that you just plug in and it works, and you can control literally everything here. Even while the print is running, you can control the flow rate, the temperature, the speed, and you can change this feed rate so you can make it go 160% or much slower, like that. And you can also change like even the speed of the cooling fan. In this bit of video you can see on the right I've got the Ultimaker robot that I 3D printed, and on the left is one by a real Ultimaker printer. And if you don't know, these are really high renowned printers. They're over £2,000 and they're really expensive but really high quality. And as you can see, there's really not much difference between the two prints. This is my one on the right and this is the Ultimaker one on the left. I think they were both printed in PLA plastic, and I think I had roughly the same settings. I don't know the exact settings, but this has got a 0.05mm layer height on mine, and it took about 2 hours to print. I'm not sure how long the Ultimaker one took to print since I didn't print it myself, but they're pretty much the same. Obviously the Ultimaker one's slightly better, but I still think my one turned out really nicely. So it has taken me many attempts to achieve that quality, and I've sort of used the Ultimaker robot as a control since it is the thing that Cura comes in with, and I also have one printed by an Ultimaker 3D printer that I picked up at Maker Faire that I can compare my own prints against. So some of these improvements in quality are from me upgrading the printer, and some of them are me getting to know my settings a little bit better. You can see the first one on the very left, I actually had my filament diameter set wrong. It thought it was 3D printing with 3mm filament, so it completely under extruded it, and this is pretty much a worthless print. I could crush it in my hands, but I quite like it. This next one was using the right settings, and as you can see, it's still not very good quality and there's a lot of problems with it, and basically this is the same just on smaller layer height, and you can see that there's these bumps in the Z-axis that aren't very nice, and I'll show you how I fixed them first. The problem was the connectors to the Z-axis stepper motors, and these flexible metal connectors, and the way that they tighten up is just with 2 grub screws like this. And the problem is, these tighten up, but the shaft wasn't actually on center, so the M8 threaded rod wasn't on center. So what I had to do was I had to put a bit of tape around it so that it was the exact right size to fit the hole, so when you tightened up the grub screws, it didn't budge it over to one side. The problem was, as it rotated and it wasn't on center, it would then shift the whole gantry left and right, creating the striations in the Z-axis. Another problem was the threaded rods weren't actually straight, so I replaced them, but the ones I replaced them with were actually more bent than the ones I originally had, so I ended up having to straighten them out by hand in a vise. So that solved the problem of there being weird wave-like striations in the Z-axis, but as you can see here, especially on this part here, it's not very good, and that's because the extruder was very heavy, and as it changed direction, before I upgraded it, as it changed direction, it would wobble and create vibrations, which would then create weird wavy lines sideways in the model, which really don't look very good, and obviously the Ultimaker one doesn't have that, so I decided to upgrade the extruder. So as I mentioned earlier, this is the stepper motor which feeds all of the filament through to the extruder, and this is essential to make the 3D printer print because it feeds through the exact right amount at the exact right time. And this is a pretty heavy motor, it's pretty dense and it's got lots of coils of wire inside, and that creates a lot of weight on the extruder, and you want this to be moving as fast as it can to reduce print times, but also when it changes direction the acceleration will create wobbles if the acceleration value is too high or if it's very heavy. And this setup, just running on these 6mm stainless steel rods, it's all quite bendy and you can move it all like that. So what I decided to do is turn it into a Bowden extruder, the same as what they have for the Ultimaker 3D printers. The way that that works is the extruder pushes it down this PTFE tubing and then into the hot end. It does mean that sometimes it jams a little bit more often, but it does create a lot better print quality. This also solves the other problems that this model of the 3D printer had with the feeding problems. So as this was fed in like this and moved side to side, it would actually pull a different amount of filament through when it was over here closer to the filament roll than when it went over here, which is much further away from the filament roll. So as it went like that, that sort of bent up the axis like this and also created poor quality prints. So once I'd done all of the upgrades, it was just a matter of messing around with the settings and getting them pretty much perfect. I did eventually slow down the speed for the outer contour so that it was less fast, therefore creating another high quality print, and then it's pretty much very similar to the Ultimaker one. The Ultimaker one is still obviously slightly better, but for my printer being almost 1/10 of the price, I'm not going to complain. Here is another example of the difference in quality for when I upgraded the extruder to the Bowden E3D version 6 hot end, and I was trying to get a Yoda head and trying to get really good detail in it, as I'd seen in lots of other prints, and for some reason my printer just wasn't doing the right detail, and that was before I realised that I needed to upgrade the extruder. So these ones on the left are all of the prints that I tried to do to get good detail, messing on with the size and the settings and everything, and it just wasn't working. But then this is after the extruder upgrade. These two files are pretty much the exact same G-code, and you can see the massive change in print quality. You can see the one on the right is so much nicer than the one on the left. All of the lines are much smoother, and it's actually surprising to see that these both have the same layer height of 0.2mm. Here is an example of a couple more of the prints that I've done using the Prusa i3, and this is an X-Wing, and these are all different Star Wars ships, and I decided to use these also partly because of the new film, which I thought was really good, and also partly because they have really good detail, so they prove how well the printer can print out different details. So since I thought it would be nice in this video if I showed some time lapses of my 3D printer printing out some more things, I decided to carry on the trend and print off another Star Wars model, and this is an AT-80 from Star Wars. There are a lot of these on Thingiverse to print off, and most of them come in different parts, but I thought it would be quite nice to mess around with the support material and try and get a really hard structure to print out that would be impossible without support material. And then if you do know anything about how an FDM 3D printer works and you do look at the final outcome of this, then you'll see all of these overhanging sections and you'll really wonder how it was made. So I sliced the model in Cura and I added support material. I only added 10% support material, so it wasn't using too much excess. And all of the different feeds, speeds and flow rates and everything are shown on the screen now. Take in mind, these are all of the different settings that I've found out over loads of different models work well with my printer. They might be different for your printer. I decided to print this in ABS despite most of my other models being in PLA, but it did start off quite nicely and the detail was looking very nice. Unfortunately, I accidentally had the extruder set too low and the leg snapped off, and as you can see here, all of the layer adhesion was really poor. So I turned up my extruder temperature to about 260 degrees, 245 degrees I think it actually was, and then I decided to print out a Yoda head, and that was the one that I showed you earlier with the improved quality, and that proved that the higher temperature fixed the layer height problem. Then I reprinted the AT-ST from Star Wars and it worked very well. The total print time was just over 10 hours, and then I can start to remove it from the build plate. So this is what the finished model looks like. I'm quite happy with it, and as you can see, all of these overhanging sections have turned out actually really nicely, and you can see the gap in between there. I managed to remove all of the support material. Some of the edges on the bottom are a little bit ragged where the support material was attached and there's a little bit of a gap, but if you look at it from above, it's still really high print quality. So that's pretty much all I can say about this printer. If you have any questions, please leave them in the comments section down below. In the future, I do plan on making a 3D printer, and I think the thing that I'm going to make is I'm going to make a ramps and RepRap clone of the Ultimaker 2 printer using different things that I can find on Thingiverse and partly my own design as well. And if I do that, I'll do a full tutorial of it on my channel and all how to put it together and everything, and I think that would look quite cool. Also, if you have any more things that you think I should 3D print, especially if they're related to the main topic of my channel, then that would be really useful, and if you could post them in the comment section down below as well. Please don't bother suggesting to 3D print a gun, because I like not being in prison. I think one thing that I might try and 3D print is a knife, maybe do a butterfly knife, since it won't be illegal, since it's not actually a knife, it's just made of plastic. And I think that would be quite cool to see if it cuts paper as well, if I can get it sharp enough.